Hello viewers, thank you for joining us in today's tutorial. This video is suitable for students in Senior 1, Grade 8. We shall be covering understanding number bases, and we shall start off with the introduction. What are number bases? Number bases are systems for representing numbers using digits. The common number bases we know have the decimal base, which is base 10, the binary base, base 2, octal base, base 8, then the hexadecimal base, base 16. There are also other types of bases. We have base 9, base 3, and so many more. But these are the common ones. Why are they important? Most of these bases you see, especially the decimal base, the binary, and then the octal base, they're used in computing, mathematics, and then we have the digital systems, majorly the bytes, to understand the data storage in computing ICT. What are the key concepts to note? There are many different bases, but decimal base is the most commonly used in everyday life. We have every base can only hold a maximum of a digit less than the base itself by 1. That is to say, for it to calculate the maximum digit, you're supposed to get the base number, subtract it minus 1, so that you can get the maximum digit that base can hold. For example, base 2, to get the maximum digit base 2 can hold, you're going to get base 2 minus 1 to give us 1. So the maximum digit in base 2 is 1. Base 3, the maximum digit is 2. How did you calculate it? 3, which is the base, minus 1 to give us 2. Then base 9, we also get maximum digit by calculating the base itself minus 1 to give you 8 plus many more. So how many digits do we have? Generally, we have a combination of 10 digits, that is from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So beyond that, we have numbers, meaning that a number can simply define it as a combination of 2 or more digits. So if you were to combine 2 or more digits, that is to say 1, 0, to make 10, that becomes a number. 1, 5 to make 15, that becomes a number. And then 9, 1, combination of 9 and 1, which are digits, making 91 as a number, plus many more. What's a decimal base? Commonly known as the base 10. It is the most common number base we use in everyday life. It has 10 digits. We said, how do you calculate the maximum digit it can hold? You get the base number minus 1 to give you 9. So maximum digit in base 10 is a 9. So examples of base 10 will have any number. As long as you list any number or any figure without a base, we purely define it as a number in base 10. So 3456 is a number in base 10. 56 without a base, it means it's a number in decimal base, something like that. So binary base. Binary base usually uses only 2 digits, that is 0 and 1. So take note of the maximum digit in base 2. How do you calculate it? Base 2 minus 1 to give us maximum digit, which is 1. So base 2, which is the binary base, is used in computer storage and the processing of data. ICT will explain best that. The example, we have 1011, so that is a binary number, and you realize that it cannot hold beyond its maximum digit. So if you said 102 base 2, you are likely not doing it the right way. So a base carries a maximum of itself by 1. So that is why you're seeing only 1 zeros in that number. There are many more. Let us look at the octal base and the base 16. So octal base, commonly known as base 8, uses 8 digits. A maximum digit it can carry it is digit 7. How do you calculate it? You get base 8 minus 1 to give us 7. It's also common in computing for shorthand representation of binary. Then we have the examples. We have 54, which is the octal. So when you write a number, then don't put the base. Someone will identify it as a decimal base, but when you write a number, then include the base. So definitely it becomes that number in that given base. We have the hexadecimal base, which is the base 16. This time around, this one uses 16 digits. Now you could be asking, you gave us a set of only 10 digits. How about the others who are going to fit in the 16 base? So this one here uses from 0 to 9, and then beyond 9, if you say 10, you'll be now writing a number, not a digit. So what do we do here? We have representations in alphabets. So you use A to F to represent given digits. A representing 10, B representing 11, C representing 12, D representing 13, E representing 14, and then F 15. So the maximum digit in base 16 is 15. How do you calculate it? Get the base, subtract minus 1 to get the maximum digit. Then where is it used? It is widely used in programming. Those who are going to enjoy programming at higher levels, it is widely used in programming and car representation in web designs. So the example, we have the A3F, so that's a hexadecimal base, something like that. So today we have to talk about the converting from other bases to base 10, which is another key important thing to note when you are talking about number bases. So what is so important here? You need to know the key steps when you are converting from other bases to base 10. The steps are: 1. Identify the base. Make sure you know what the base is. Write as powers of the base. If it is base 2, make sure you write the numbers as powers of base 2. Then you have to multiply the digits by powers of the base, that is to say the values. So multiply the digits by powers of the base. In simple terms, you're getting the values of the given number. Then the last one, you get the sum of the products. So the number you get will automatically qualify to be under base of 10. Let's look at the example. Convert 11001 base of 2 to the decimal base. We start off by identifying the base. The base is 2. After identifying the base, you give powers to the base with respect to the base. So that means I'll give powers in descending order, that is to say from small to big, from my right hand side. So that means 1 will have the power which is 0, then 0 will have 1, and then 0 will also have 1, then we shall have 1 having 3, and then another 1 having the power of 4. So in simple terms, when you look at giving powers, you start from the right hand side: 1, 2, 3, 4, and then we shall have 5, something like that. So in simple terms, we are starting from 0, 1, 2, 3, 4. So after that, what do? You multiply by the powers of the what? Of the base. So 1 times 2 to the power 4 raised to the power 4. In simple terms, we are multiplying by the value of 1. So 1 times 2 to the power 3, 0 times 2 to the power 2, then 0 times 2 to the power 1, then finally 1 times 2 to the power 0. So when you raise this to power 4, you get a 16 times 1, 16, then the 2 to the power 3 is 8. Sorry, 2 to the power 3 is 8, and then times 1, that's 8, then a number multiplied by 0 gives us a 0, a number multiplied by 0 gives us a 0. Then 1 times 2 to the power 0, any number to the power 0 is given as 1. So 1 times 1, that's why you're seeing 1 appearing here. So 16 plus 8 giving us 24, 24 plus 1, 25 base 10. So generally the conversion is not a difficult task. The concept is you should be knowing the steps following. The first step is identify the base, give the numbers powers starting from the descending part, That is to say, from the right hand side moving to the left hand side, increasing the power by 1. So that means here it is 0, 1, 2, 3, and then 4, something like that. So from there, what do? You get the product of the number of the digit by its place value or a value. Then after that, you simplify to get your output. So some quick practice. I expect you to convert the following bases to base 10 during your free time to practice more. So we have 246 base 7, 1001 11 base 2, 562 base 8, 183 base of 16, 123 base of 4. So I expect all those to be converted to base 10. Then you have to submit in later. Converting from base 10 to other bases. So let's look at another scenario, which if you're given an base 10 and then you're told to convert it to other bases. What are the key steps? The key steps are: 1. Divide the number by the new base, record the remainder, repeat the division, continue until the quotient is 0. Then you also write the remainders in the reverse order. Let us see how it is done. So we are converting 156 to base of 5. The key concepts are: you are supposed to draw something of this kind so that it aids your work. So I expect you to do the following. 1, you should have a base, then you should have the number, you should have a remainder. So in simple terms, we are dividing which number? The number is 156. Then we are dividing by which base? In simple terms, what are we converting it to? Converting it to base of 5. So we divide throughout by 5. That's by 5. 156 by 5, you get 31. So 31 times 5, it means it will go there 155 times. So the remainder, 156 minus 155, you get a remainder of 1. That's why you write the remainder on this column here. Then 31 divided by 5, you're going to get 6. So it means it's going to go there 30 times, and the balance 31 minus 30 gives us a 1. So 6 divided by 5, you continue dividing until the quotient is 0. That's what the steps were telling us to do. So by 6 divided by 5, you get 1. You get because there are ones, remainder of 1, and then 1 divided by 5, you get there 0, remainder of 1. So we write the answer in reverse order, from down moving up. So that's the concept. You write the reverse in a reverse order, from down moving upwards, something of that kind. So writing the answer to give us 1 1 1 1 1 base of 5, something like that. So the concept is simple. Make sure you have the base, number, remainder. Divide the number not until the quotient is 0. The output of the remainder, write it in a reverse order to give you the output, something of that kind. Let's look at the quick practice. See? Okay, let's look at the quick practice here. So I expect you to have the key guidelines for converting from non-decimal base. So the quick practice is that convert the following bases indicated: 347 to base 3, 298 to base 8, 289 to base 6, 512 to base 4. So something of that kind. So let us look at how do you convert from non-decimal base to another non-decimal base. The key concepts are: when you're converting from a non-decimal base to another non-decimal base, what do you do? 1, convert the number to the decimal first. To converting it to decimal, then you have to convert the decimal to the new base, something of that kind. So I expect you to do the conversion of this quick practice here: 11010 base 2 to base of 8, then convert 127 base 8 to base 7, something of that kind. Then the research work, you have to research the names for bases from base 2 to base of 12, give them their common name and then their other names. For example, base 2 is binary base, you continue like that. Base 9 is binary base, something of that kind. Then you also have to research on the common applications of bases in real life situations. So the scenario based question, so this is the part I will leave you on. I will expect you to do more research on the scenario question. So I have the first one. Mr. Ivan is an old man who is rich and has a bank account. He has been saving in this account for many years, and now it is time to make a withdrawal. He encrypted his ATM pin in a 2337 base of 8. The bank has failed to give him the money because of an incorrect pin, so he doesn't know how to convert this to base 10. Can you help him out? So I expect you to answer that task. Then item 2 in the scenario, Yam is working on a separate project in his robotics club. The team uses a special code to track their progress, and the code is 312 base of 4. Yam knows the code will reveal the key to their next step, but there's a catch. The system only understands codes in Octobase. Help him crack the code. So when we meet again, we shall have to talk about next chapter, working with integers. It will be our link to start off next time. Thank you for watching.